An important technique which the researcher has access to is heuristic analysis. Heuristic analysis is an expert UX method in which a practitioner analyzes and assesses an interface according to a set of heuristics. Heuristics can be thought of as professional principles. If we have a way to analyze interfaces with a set of principles, then it may be tempting to some practitioners to avoid testing the interfaces with users. This is not a good idea. An expert analysis by a UX practitioner will not find the majority of the problems that exist within an interface. Only insight gained through research with users will uncover the majority and hidden usability problems within an interface. However, the heuristics will uncover many problems. Further, the heuristic analysis technique can be shared with other team members. Ideally, if a few people on a team were to perform the heuristic analysis on the same interface, many more issues will be uncovered than with only one individual doing the analysis. There are a few indicators which a UX practitioner should pay attention to as part of the analysis. One indicator is related heuristic. The heuristics that are related to the observation should be noted. Description. A description of the issue observation. Location. Where the observation occurs within the product or interface. Frequency. The number of times the problem occurs should be noted. And severity. The degree of seriousness of the problem from minor to severe. The most often cited heuristics were developed by Jacob Nielsen and Rolf Molek. They are visibility of system status. Websites need to give visual feedback about the current state or status. Users need to know where they are within the website, as well as the path which they took to get there so that they are able to backtrack. Match between system and real world. The website messaging should be in natural real-world language rather than programming terms which are context-specific to the site. Only developers would understand the technical language. User control and freedom. Users should be provided with the ability to fix information and undo actions they've taken. Users need to feel that they are in control. Consistency and standards. Standards must be followed. There must be consistency with the presentation of different services. Error prevention. The design should try to detect error conditions and to attempt to prevent the user from entering into those error conditions so as to assist the user to not enter into problems. Recognition rather than recall. The human memory cannot keep track of too many different items. As such, the design should reduce the cognitive load on the users by making as many options and items as visible as possible. Flexibility and efficiency of use. Users need the ability to customize their experience, especially for frequently performed actions. Aesthetic and minimalist design. There should be no visual clutter within the interface. There needs to be a purpose for every element within the interface. Help users recognize, diagnose, and recover from errors. Error messages should be in natural, non-technical language and with a clear explanation as to the fault and how to rectify the issue. Help and documentation. Help information can reduce difficulties that some users may experience.